Hello, my name is Isaiah Stapleton. I work on the Red Hat research team and in the Mass Open Cloud, and today I'm going to be going over how to properly configure an OpenShift cluster for model serving on Red Hat OpenShift AI. So the purpose of this demo is, as I said, to take a newly installed OpenShift cluster and properly configure it for model serving on Red Hat OpenShift AI. For this demo, I'm going to specifically be using the VLLM serving runtime for kserve, but this setup should work for any of the kserve serving runtimes. Along the way of this guide, I also want to provide clarification for why each step is actually required for model serving. The picture here, you can see a list of the serving runtimes that come installed by default with Red Hat OpenShift AI, except for Llama CPP, which is a custom serving runtime that I added. But all the other ones come installed with Red Hat OpenShift AI by default, and you can see most of them are for kserve. So by using this setup, you should be able to use any of these serving runtimes, but the one that I'm going to be going over and using in this demo is the VLLM serving runtime for kserve. Here's a list of the operators that we are going to be installing today in this guide. I'm not going to go over what each of them does right now, since I'm going to be talking about that later during the guide, but here is all of the operators just listed out now for you to see that we are going to be installing today. The first step for configuring your cluster for model serving is to enable GPU support. Throughout this guide, I will be referencing this repository. It contains a README with the steps that I'm about to show today, as well as the manifest for deploying the different operators and configuration pieces. So the first thing that we'll need to do in order to enable GPU support in the cluster is to install the node feature discovery operator. This operator is required for detecting and labeling GPU nodes. In my current setup, I have a GPU node, work3, and if I take a look at the YAML, there's nothing inside this YAML that actually shows that this node contains a GPU. I could type GPU, I could type NVIDIA, but nothing shows up. So the cluster has no idea that this node actually contains a GPU. So if I was to deploy a GPU workload or deploy a model, it would end up on any node, possibly one without a GPU, which we obviously do not want. So in order to have the proper functionality that we're looking for, we need to install the node feature discovery operator so that this node is properly labeled as a GPU node so that I can schedule workloads and models on this node. So before we actually install the node feature operator, let's take a look at the manifest that actually installs this operator. So we can find that in manifest O1 NFD operator. So this manifest basically defines three things. It defines the namespace that the operator will be deployed in. It defines the operator group. The operator group basically just specifies which namespace an operator is allowed to manage resources within. And then the subscription for the operator. This subscription is actually responsible for installing the operator in your cluster. And the channel that the operator is set to is stable. So if you apply this manifest to your cluster, it will install the version of the operator that is set to the stable channel. So let's now actually install the node feature discovery operator. First, I will clone the repository that has the manifest for installing the operator, as well as the subsequent operators. CD into the directory, and then before I actually run the command to install the operator, I will mention that I am already logged into my cluster through the CLI by copying this login command. Make sure you have done this so that you actually deploy the resources on your cluster, as it won't work without being logged into your cluster. But since I've already done that, I will just go and run this command. And you need necessary permissions for doing so. So for my cluster, I need to run this command as system admin so that it actually installs it properly. So I will do that now. I've waited a couple minutes so I can actually verify if the operator has been installed by checking the pods in the namespace that the operator was installed in. So you can see here the pod for the operator is in the running state, so we are good to go to the next step. So now that the node feature discovery operator is installed, we need to apply a node feature discovery instance object. So after the operator is installed, you must apply this instance object in order to deploy the NFD daemon set, which scans the nodes for the hardware features and labels them accordingly, in our case for GPUs. So I can run this command now. And now the NFT instance is created. The next step is to install the NVIDIA GPU operator. This operator is responsible for managing NVIDIA GPU resources. It's also able to expose metrics related to your GPU hardware, such as utilization, temperature, memory usage, etc., although that is outside of the scope of this guide. So I will install the NVIDIA GPU operator now. Now that these resources are created, I will wait a few minutes so that everything can get up and running. We now need to create and apply a NVIDIA GPU cluster policy. This cluster policy is the core custom resource that defines how the NVIDIA GPU operator manages GPUs within our OpenShift cluster. So it essentially serves as the central configuration for the operator. So before I run this command, I actually just tried to run it and I realized I needed to make the scratch directory first. So I will do that really quick and then I will run this command to create the cluster policy. And now we can see that we have the JSON for the cluster policy. And now that we have that, we can go ahead and apply that cluster policy. Now that I've applied the cluster policy, I can check the NVIDIA GPU namespace and see the resources being created. So you can still see some of the pods are still initializing, so I'll give it a few more minutes. Some time has now passed and I can see that the NVIDIA GPU operator pods are now all up and running, so everything should be all set now. Now that we've gotten that all set up, let's just take a quick look at the work3 node YAML again that we looked at earlier. You can see now that it has a lot more annotations that include hardware information about this node, including information about the GPUs. You can see here that this node has 4 GPUs and that they are NVIDIA A100s. So now my cluster should be properly configured for using GPUs and running GPU workloads. And to make sure of this, let's just run a sample GPU workload. This workload is just a simple workload that runs some simple vector additions on the GPU. I've already created the sandbox namespace, so I will make sure that I'm in that namespace. And then I will create and run the GPU workload. Okay, this workload has been created. We can get pods and we can see that the container is being created. So we will give that a couple of minutes and let it run, and then we will check the output of the pod in a minute. A couple of seconds have passed and let's check the pod again and we can see that it has completed. So let's just check the logs and we can see that it was successful in doing a vector addition on the GPU and it returned this output. So everything looks good. Our cluster is now configured properly for GPU usage and running GPU workloads. And so now we can go on to the next section where we're actually going to go into the model serving part where we are going to install the Red Hat OpenShift AI Kserve dependencies. We wish to use Kserve because it provides efficient model serving capabilities, enabling deployment, inference, and monitoring of AI models within Red Hat OpenShift AI. First, we're going to install the OpenShift Service Mesh operator. This operator is required for managing communication between model serving components in multi-model serving scenarios. So please note that this is only required in a scenario in which you are using multi-model serving capabilities. If you're just doing single model serving, this isn't technically required, but I'm still covering it so that you can properly configure your cluster for both single and multi-model serving. So let's go ahead and install the OpenShift Service Mesh operator. And we can see that the subscription has been created. So let's give it a couple of minutes and see that the resources have been created and are up and running. So some time has passed. We can now check if the operator pods are up and running. The operator was installed in this OpenShift operators namespace. So I'm going to check the pods in this namespace. And I can see here that this pod, the istio operator, is indeed running, and that is what we are looking for. So we are all good on this step, and we can go to the next step. Now let's install the Red Hat OpenShift serverless operator. This operator is required because it provides Knative serving. Knative serving enables serverless functionality in OpenShift, which is important for us in the model serving scenario because it allows the model service to scale automatically based on incoming traffic or workload demands. So let's now install the OpenShift serverless operator. Okay, so we can see the namespace, operator group, and subscription have been created. So let's just give it a few minutes like we have before so that all the pods for the operator can get up and running. So a couple of minutes have now passed. Let's now check on the status of the operator pods and see if everything is up and running. This operator was installed to this OpenShift serverless namespace, so let's check the pods in this namespace. Okay, awesome. So all of the pods are up and running, and so the OpenShift serverless operator has been installed successfully. So we can move on to the next step of installing the Red Hat Authorino operator. The Red Hat Authorino operator is required for us because it provides authentication for API requests to AI model endpoints. So it's not necessarily required in the sense that you need it for model serving. However, without this operator, there is no authentication for your AI model endpoints. So anybody can basically go and query your AI model endpoint, which is a functionality you probably do not want. So we need this operator so that only those with proper credentials can go and query your AI model endpoint. So let's go ahead and install the Red Hat Authorino operator now. All right, and the subscription has been created. So just like before, we will wait a few minutes so that all of the pods can get up and running. Some time has now passed, so let's check on the status of the pods. This operator was installed to the OpenShift operator namespace, so let's check the pods in that namespace. And we can see here the Authorino operator and Authorino webhook pods are up and running. So we now have installed successfully the Red Hat Authorino operator. So after these three steps that we just did, we now have all of the necessary Kserve dependencies for Red Hat OpenShift AI. So now that we have all the necessary dependencies installed, let's go and actually install the Red Hat OpenShift AI operator. This is likely going to take more time than we had to wait before for the other operators, as there is more involved in this setting up this operator. So we will wait some time and then return and check on the status of the pods for the Red Hat OpenShift AI operator. So a few minutes have passed, and we can see if we get the pods from the Red Hat ODS operator namespace. You can see that the Rhodes operator pod is up and running. So for the last step, we need to apply the data science cluster CRD. The CRD is essentially the configuration for the main components of Red Hat OpenShift AI, kind of similar to the cluster policy CRD for the NVIDIA GPU operator. So let's actually take a look at the data science cluster manifest, which you can find within manifest 3 in this Red Hat OpenShift AI operator dsc.yaml. So this is the data science cluster CRD that we will be deploying. Within the manifest, you can define which components you would like Red Hat OpenShift AI to manage. You can see here for Kserve, you can set it to manage so that Red Hat OpenShift AI manages the deployment of the different Kserve components for you. So we have all of the necessary dependencies for Kserve, and now we can actually specify Red Hat OpenShift AI to do the deployment of Kserve for us, which is perfect. So let's go and actually deploy this manifest and deploy this data science CRD. So the CRD has been created, and we will now need to wait again a few more minutes so that all of the different components can get up and running. So a few minutes have passed, so everything should be up and running. Let's just take a look at the OpenShift console, and let's just look at everything through here. So after we installed the Red Hat OpenShift AI operator, we had this namespace with this Rhodes operator pod, which I'll note really quick. It's called Rhodes because it used to be called Red Hat OpenShift Data Science. It's now Red Hat OpenShift AI, but some of that old terminology still applies. So if you see that, that's what that means. Um, but after we applied the data science cluster CRD, we had resources that were created in this Red Hat ODS applications namespace. So we can see all of these pods are indeed up and running. And we also configured Red Hat OpenShift AI to manage the kserve deployment for us. So we have this namespace knative serving, and we can see all of the kserve components are running here, and all these pods are up and running. So just based on looking at these pods, everything looks like it is up and running. And if you select these 3x3 icon here, which I refer to as a little meatball, if you select the little meatball, you will see the Red Hat OpenShift AI link here. So you can click that. So I will go over in another guide how to actually deploy a model on Red Hat OpenShift AI now that you have your cluster properly configured for doing model deployment. But first, let's just take a look around Red Hat OpenShift AI and the current setup that we have. So let's take a look at the settings over here. This actually, if you notice, this didn't show up a minute ago. I had to add myself to a certain group, this Rhodes admins group. So once I added myself to this Rhodes admins group, I had the necessary permissions to now see the settings. You can see different things in here if you want to add certain notebook images, change the cluster settings, add an accelerator profile, which pertains to the GPUs, and then the different serving runtimes. This is what I wanted to show you mainly in the settings was the serving runtimes. This is all of the serving runtimes that come pre-installed with Red Hat OpenShift AI. You can see most of them are pertaining to single model serving. The only multi-model serving platform that comes out of the box is this OpenVINO model server. So if you have your own serving runtime you want to use, you can go and add your own custom serving runtime here. The one that I will be using is this VLLM serving runtime. That's what I will be using in the upcoming guide for actually deploying a model on Red Hat OpenShift AI. So this is the one that I am most interested in, this VLLM serving runtime for kserve. So let's actually just go into the data science projects and let's just deploy a workbench with a GPU. We don't have to actually deploy a model yet. Like I said, I'm going to be doing that in another guide. But let's go into that namespace we created earlier, the sandbox namespace. Let's go to workbenches. Let's create a workbench. I'm just going to call it demo. And then I will select an image. Let's use the PyTorch image. I'm fine with the small container size, and then the accelerator I'm going to select is the NVIDIA GPU. So the accelerator profiles, let's actually just take a look at that really quick. So if you look at the accelerator profiles, basically all it's doing is identifying, how to schedule, which node to schedule your workload on, or in this case, the workbench. So remember when we looked at the work3 node earlier, it had this identifier nvidia.com slash forward slash GPU. So it is from this accelerator profile that OpenShift AI knows which node to schedule models, workloads, and workbenches on. So I'm going to select this NVIDIA GPU accelerator so I can schedule it on that GPU node I have. I'm fine with the default PDC settings, so I'm just going to create the workbench. This usually takes a few minutes, so I will just wait a few minutes and wait until the image is up and running. The image is now up and running, so I will just open it, and this will bring me to the Jupyter Lab environment that I have just spun up. And I'm just going to do one thing in this environment, and I'm just going to check if I have access from this workbench to one of the GPUs. So you can see from running this NVIDIA SMI command, this workbench is actually able to access one of the GPUs. So it was scheduled on the GPU node and it has access to the 0 GPU, which is one of the 4 NVIDIA A100 GPUs that are on this node. So you are now able to spin up workbenches with GPUs, and you can use this environment to do any of your AI work that you want to do. And like I said, in the upcoming guide, we will go over how to actually do model deployments in this environment. Congratulations, you now have an OpenShift cluster that is properly configured for doing model serving on Red Hat OpenShift AI. Like I mentioned, I will be creating another guide for how to actually deploy a model on Red Hat OpenShift AI. Specifically, I will be going over how to deploy the Granite model using the VLLM serving runtime for Kserve on a NVIDIA A100 GPU. Over these next few days, I will also be fleshing out the README for the guide that we went over today for configuring the cluster. So hopefully that may fill in any gaps that I may have missed in today's video demo. If you have any questions or concerns, feel free to open up an issue on the repository that I referenced multiple times throughout this video. And you can also reach out to me through my Red Hat email. I hope this guide was useful for you. And like I said, please reach out to me with any questions or concerns or any ways that I could possibly improve this guide for others.